In topic 3 of chapter 5, we are now going into polynomial equations and then solving these equations by factoring. And we use the principle of the zero product. And we're going through some of the techniques of factoring. So whenever two polynomials are set equal to each other, the result is a polynomial equation. In this section, we learn how to solve polynomial equations algebraically by factoring. So far we've been multiplying, and now we're going to undo the multiplication. So let's take a look at this. So here we see this is a quadratic equation, so we just can't solve it for x. So what do we do with something like this? Well, we put it in what we call standard form of the quadratic equation, which is over on the left, getting all of your regular terms, and then have it equal to 0. And we're going to talk now about 0 and roots. The x values for which a function f of x is 0 are called the zeros of a function. And I'll give you an example of that shortly. The x values for which the equations such as f of x, and here we're looking at these x values right here, is 0, are called the roots or solutions of the equation. The principle of zero product. Now, we're going to go over this very carefully because this is so important in this lesson. It says for any real numbers a and b, if you multiply a times b and it equals 0, the only way that that can be true, remember a is a factor, b is a factor, and we're saying this factor times this equals 0. The only way that that can be true is if either a or b is equal to 0. Okay? Now what's this called? The principle of zero products. Now, here we're seeing our first example. So let's take a look at it. And we have here think of this as if it were a, and this indicates times, and this is b, and we're saying a times b is equal to 0. This is the principle of zero products. Now, what are we saying is a? Well, we're saying this is a, and this is b. And we just said that if the way we solve it is that either this is equal to 0 or this is equal to 0 in order for the product of this to be 0. So here's how we do it. This, in a sense, it's in its factored form. We go x minus 4 is equal to 0, or x plus 3 is equal to 0. So now we solve this. What is x going to be? Well, x and we just transpose that is 4, or x transpose that is a negative 3. So here, if we put a 4 in here, 4 minus 4 is what? 0. So 0 times anything is 0. And if we put a negative 3 here, negative 3 plus 3 is 0. 0 times anything is 0. So these are our roots, which is another word for solutions. Okay, let's go on. We'll try some more. And they're going to show you the process that I just did. Now, interestingly, if this were in its regular form, and in fact, let's put it in its regular form, and if I FOIL this, I get this quadratic expression. Equaling it to 0 becomes a quadratic formula, and this is standard form. But in order to solve a quadratic equation, we're going to use the principle of the zero product. That is, we're going to factor that back to its factors, take each of the factors, equal it to 0, which is what we've done, and we get our roots, a 4 and a negative 3. Now notice, if you were to put this in a graphing calculator, this up here, and say graph it, this is what the graph would look like. It's a parabola, quadratic equation, and notice it's crossing the x-axis right there and right there. And what are the coordinates of these points? Well, x and a y. Y is a 0. X here is a negative 3. Ah, look at right there. And here it's x and y again. X now is a 4. Ah, right there. So what we're doing here is finding the zeros. That is, what are your x-intercepts? From an earlier chapter. It's where your line crosses the x-axis. There's also a y-intercept down here that we're not looking at right now. We just want to find the zeros. So when y is a 0, this is our x-intercept. And we found it by using the technique of having an equation in standard form, factoring it, taking each of the factors, equaling it to 0, and then these are our x-intercepts, which are the roots. Okay, and you'll be practicing this as we go on. And the check of it is that it's true. Okay, now we're going to do a little more in depth this idea of factoring things out. So when we multiply, let's say 4x times this trinomial, we just distribute the 4x to each of these terms, multiply, and we get this. Now, when we have this, and I had mentioned this in an earlier lesson, and we take out a common factor of each term, which happens to be the greatest common factor, the 4x, we get back to what we had originally. So factoring and multiplying are sort of the opposite of each other. And that's what we'll be doing. and bringing in what we did in sections 1 and 2 will be useful. So now we want to factor this. So there is a strategy, a protocol, a modus operandi to do it. We're going to have two terms in a parenthesis, and this is sort of the background, and we want to factor something out, the greatest common factor. Now, I know I can take a 4 out of there, so I'll put the 4 there. I'm going to take a 4 out of there and a 4 out of there. And what factor of x can I take out of each one of these? Well, the greatest one I can take out of each one is x to the third. So it would be the smallest degree of our exponents here. So now what's left here? Well, 4 times 7 is 28. And then I've taken out x to the third, so what I have left there is x to the third. Now, 4 times what is 32? 8. And I've taken out the x to the third already. So how do you check these? Well, you just distribute again as your check, and it does check. Okay? Now again, we're just doing some practice now in factoring. And they're showing us different techniques. And there's our answer. Okay, now let's factor this one. So as we look at it, we have 3 terms. So I'm going to need a parenthesis like so for 3 terms. I'm going to see what the greatest common factor I can take out of each one of these. Now as I look at them, for the number part, I see I can take a 3 out of there, a 3 out of there, a 3 out of there. So the greatest common factor is 3. Now I have x to the 5th, x to the 4th, x to the 3rd. So the smallest one that I can is the one I have to take out of every one. So it's going to be x to the 3rd. So what's left here? Well, this is going to be 4x squared, because if I multiply this, I get that again. I'm going to put a negative there. And here I'm going to take a 7 out. I have x to the 3rd out of there, which leaves me with x to the 1st. And then here it's going to be 3 times 8. And I've taken out x to the 3rd already. So again, I check it by distributing, and it does check. And that's what we had. Now here we're using a special technique that's called factoring by grouping. And notice this is one term. There's the plus, this is one term, because these are factors of each other. So that's just right now is one term. But can you see I have a common factor right there? So I'm going to factor that out of both of these terms as x plus 2. And then what's left? Well, I have an x squared from there and a plus 3 from there. So I have factored this common factor of x plus 2 and then brought these in. Now notice if I were going to multiply this, I would, and they use a little different technique, but I would take this and multiply it by that, and I would take this and multiply it by that, and that's what we have here. So we have factored this. Okay, now I've written that and switched it around, but that's fine. So let's do letter A. Now, when we are factoring by grouping, traditionally there's going to be 4 terms, and we're going to see if we can take something out of our first 2 terms. And I can see I can take a 3 out and an x squared. So here I'm left with an x plus 3. Now notice in my last 2 terms, there's an x plus 3, which is what I have here. Now out of anything, you can always factor out a 1. And that's what I've done out of these terms, because if I distribute this, I just get that. But I can factor a 1 out. Now you'll note that I have common factors right there. So I'm going to put those right here. And then I'm going to bring this one in there and this one in there. Now I've gone from a 4-term, single-term expression into a factoring of 2 binomials. Now if I FOIL these, I would get that up there. Or take this, multiply it by that, and this, and multiply it by that. Well, I have the wrong one. It's this one here. Sorry about that. Okay, so anyway, that was a good one. Let's try another. Now, instead of giving us a few easy ones to work, they give us a challenging one for this next one. So as we look at these 4 terms, is there a common factor I can take out of each one? And the answer is yes. I could factor out a 3 from all of these. So that's what I've done. And then I have this. Now I'm looking for what can I possibly take out of these first 2 terms. I could take out an x, which I did. And what can I factor out of these next 2 terms? So I end up with what I have here. Well, in this case, I have to factor out a negative 3. That will reverse the signs, and I get this. So then, what is my next step? Well, I have 3 that I need from out there, and I'm going to put this, which is a common factor now in both of these, and then I have an x minus 3. I take this one from there, this one from there, and I'm multiplying it by this common factor here. Again, this is more of a challenging one. I'm assuming you're going to have more like this one that were a little bit easy. Factoring by grouping. And that was the first one. And here's the second. Again, they're getting a little different answer than I did, but I guess that's okay. Oh, see, they're factoring out that 3 there. Okay. I did that first. I think that would be the better way to do it. And the answer comes out the same. All right, that's better now. Okay, now let's get back to using factoring to solve equations. Again, we're looking for zeros. So our first thing is we're going to put this in standard form. Transpose that and equal it to 0. Now, what can I factor out of these two terms? A 7x. And I get an x minus 5. Notice if you just distribute, you get back to what you had. But now our routine is we're going to take each of these factors. Remember, we're using that technique that we're going to equate each of the factors to 0. So this is going to be 7x equals 0, or x minus 5 equals 0. So here we divide both sides by 7. We get x equals 0, and that's a good answer. And then here we're going to have x equals a positive 5. Now if we put that up here, that actually checks, because if this is 0, 7 times 0 is 0. 35 times 0 is 0. But how about if it's 5? Well, it would be 7 times 25. 5 squared is 25. And then it would be 35 times 5. And these are the same. This is 175, and this is 175. So they check. Okay? So both of these answers solve this equation. How did we get to it? We got to it by putting it in standard form, factoring out the common factor for our zero principle of the zero products, equate each of our factors to 0, solve it, and this is called finding the zeros. Putting it in standard form, factoring it, equating each of the factors to 0, and there we go. And we checked it. So when we're using the principle of the zero products, we put the equation in standard form. That is, all the terms on one side equal to 0. We then factor the non-zero side, set each factor to 0, and then solve the resulting mini equations. Okay, that'll wrap this up.